Okay, you guys, the last review video of this week, and this time we're still going to be talking about right triangles, but we're going to be looking at very special right triangles. Again, pretty famous for our trig class. So let's consider these next two examples, right? So I've got this right triangle here and this right triangle to the right. And what I wanted us to do is I want us to find the missing sides. All right, and so when we look at this, either one, right, we're only given one of the values. You know, you might call that A and B and C. So if I tried invoking the Pythagorean theorem, we would get 7 squared, let me bring this down, right, plus B squared equals C squared. And so it's kind of impossible to solve for the remaining variables because we only have one equation and I have two unknowns. So I would have to be given more information in order to find it. Same thing would happen here, right? We're only given C and we don't know A and B. So again, we would be stuck using the Pythagorean theorem. So the Pythagorean theorem is kind of no good here, right? Even though it still applies, it's not very helpful here because we have two unknowns. So it turns out though that these triangles are very special. Let me talk about each one and then we'll go back and solve them. So for a 45, 45, 90 triangle, that's what this first one is. If this is 45, we know that's 90. That forces this side to have to be 45 as well, because the sum of the angles equals 180 in any right triangle. So what we have is a 45, 45, 90 right triangle, and we have a lot of symmetries involved. If these two angles are the same, that means that these two sides have to be the same. So we automatically know that the two sides have to be equal. So if one side is 7, the other side has to be 7. So that is a pretty good one. So it doesn't matter. How about I just kind of draw some general right triangle here, right? So here's 45, 45. That would have to be x and that would have to be x. So these sides are the same. So what about the hypotenuse? Well, let's go back. Now that I have two sides, we can now use my Pythagorean theorem. So 7 squared plus 7 squared is equal to C squared. So 49 plus 49 is C squared. I'm going to write this as 2 times 49 for some reasons that'll be clear in a moment. So to find C, I have to take a square root, introduces a plus minus. So C becomes a square root of 2 times 49. And of course, if we simplify this, we get 7 square roots of 2. So this side would be 7 square roots of 2. And of course, that's kind of helpful now because if this side's 7 and this side's 7, notice that the hypotenuse is basically that 7 times the square root of 2. And so there's basically kind of a famous formula, if you would, for a 45, 45, 90 degree triangle. So this relationship always has to be the same. This side was x, this side is x. The hypotenuse is always whatever that x is times the square root of 2. All right, and so get that into your memory boxes because we'll be using it quite frequently. All right, and so what about a 30, 60, 90? Well, this situation right here, right, we have a right triangle. We're told that that angle is 60, so that forces that angle there to be 30, right? And what we have is 20 centimeters on that side. Harder to see here because we don't quite have the same nice symmetry going on. So let me cut to the chase. It turns out that this side here is always going to be 2, right, times whatever A is. And this side here is going to be whatever A is times the square root of 3. Putting it in a formula way, right, this side that is opposite the 30 degree angle we'll call x, and that determines everybody else. If this side is x, the hypotenuse is double that x, and this side is x square roots of 3. And so there would be a relationship amongst those three sides. And so if this is 20, that would mean that this side would have to be 10, and this side would have to be 10 square roots of 3. So because of that pattern, I don't even need the Pythagorean theorem anymore, right? I just use the pattern, all right? And of course, that it can be proven with the Pythagorean theorem. X squared plus x square root of 3 squared does that equal 2x squared? Well, that's x squared, that's 3x squared, and that's 4x squared. So 4x squared equals 4x squared. So since the Pythagorean theorem is always true, that means my relationship in a 30, 60, 90 is always true. So again, to review that, the side opposite the 30-degree angle pretty much determines everybody else. Once I have that, the hypotenuse is double it, and the other side, if you want to call it b, is whatever that side is times the square root of 3. And so that gives us a pattern to basically use rather than the Pythagorean theorem. So let's go use it. So when we come down below here, let me make sure those patterns are still there. When I come down below here, what I notice is I have a 45 degree triangle. So that means this side's x, and this side's x square root of 2. So I basically need to find out what x is, but I'm given the hypotenuse. Well, luckily we can simplify that, right? The square root of 18 is the square root of 9 times 2, which is 3 square roots of 2. So the x that we're looking for, right, we're looking for x square root of 2, right? X is equal to 3. So this side is 3 and this side is 3, and I guess that would be in inches, right, if we were talking about lengths of sides. So we're good to go. All right, so 3 and 3, and then square root of 18 is what I have for my sides. Next one, we have a 30, which forces this to be 60, right triangle. So the side opposite of 30 is x, the hypotenuse is double x, and the remaining side is x squared to 3 based off of the pattern that I saw. So the pattern remains the same no matter the orientation. So we already know what x is. X is 5. So this means that this is 2 times 5, giving us 10. And this means that this is 5 square roots of 3, and I guess that would be in meters and meters. So we basically found the missing sides for that 30, 60, 90 right triangle. Okay, and as been part of the course, again, since there's not a lot of homework on this, I want to make sure there's some discussion on it. I'm going to leave C and D for Canvas. Okay, so take what you've hopefully learned from me in this part of the review and try to apply it to find our lengths of our missing sides for C and D. All right, so that should wrap up our review. Make sure you guys are discussing things on Canvas and giving your Canvas points. Let's get ready to do some full-on trig coming up in a couple of weeks. Talk to you guys later.